In this clip, I'm going to talk about definite integral. First of all, how to write it. We also use the integral sign, but we put two numbers, one here, let's call it a, and one here b. In practice, they could be actual numbers. We have a function f. Let's assume f is continuous. Not always necessary, but just to be safe, we'll deal with continuous functions. So I have the integral, and we say from a to b of f of x dx, and this is how it's written. Now, how do we define it? There's actually two definitions, and there's a fundamental theorem of calculus that says they're the same. One of them is geometric, and one relates to the indefinite integral. And I'll go with the geometric definition first. I've brought in a picture I found on the internet to illustrate this. So here we have a pair of axes, x and y. Here's the graph of the function f of x. Here are the points a and b here. Usually a is on the left, b is on the right, but not necessarily. But for the moment, we'll assume a is on the left, b is on the right. If not, you'll have to reverse the answer. So the integral from a to b of f of x dx, as written here, is just the area that's between the curve and the x-axis. Also going to assume that here we have a positive function. If a is bigger than b, if a is on the right and b is on the left, then we just take minus of the answer. So I would say that the integral from b to a of f of x dx is minus the integral from a to b of f of x dx. That's one thing. So we can always assume that b is on the right, and if not, we just reverse and take the negative answer. The other thing is, in this picture, I assumed that the function was above. In general, that may not happen, so I'll bring another picture where f goes from a to b, but it's sometimes positive and sometimes negative. And in this case, it's not exactly the area under the curve, or it is in a sense. If the curve is above the x-axis, we take this area with a plus sign, and the bits that the curve is below the x-axis, we take those areas with a negative sign. So this is like a negative area, and then a bit of positive as well. So we have this minus this plus this. That will be what we call the definite integral from a to b. Okay, I'm not going to go into much more detail than that. There are exercises later on areas and things. But what I do want is the other definition of the definite integral, which ties in with the indefinite. Suppose I have a function capital F of x, which is the indefinite integral, which is written also with this symbol, but without anything written here and here, of f of x dx. That means that f is an antiderivative of f. Usually we can't determine it precisely, so we put this constant of integration, but in any event it means that f prime of x equals f. So let me just say that f will be one specific antiderivative. Choose a particular c, just fix some f. Then the other way of defining the integral from a to b of f of x dx is just the antiderivative, the indefinite integral, applied to the point b minus f applied to the point a. There's a mathematical notation when you take a function, substitute two values and subtract. That's just f of x, then we put a vertical line, and we put here a and b, which means substitute x equals b, x equals a, and subtract. Sometimes we emphasize it by putting x equals. There's a more old-fashioned notation which puts it in square brackets, and then you put the a here and the b here. But basically, if you see an expression, not an integral, with a number on top and bottom, usually means substitute this, and subtract. I want to point out that the c would not make any difference. Suppose I took g of x is equal to f of x plus 5, just, some constant. And then, if instead of f I use g, I mean g of b minus g of a is going to come out the same, because g of b is going to be f of b plus 5 minus f of a plus 5. The 5's are going to cancel, and it's just going to be the same as this. Whatever constant I put, it's going to appear plus and minus, so it really doesn't depend on which primitive or antiderivative you choose here, so you don't really need the c. Let me just show you in practice using this thing how we go about writing it. I'm not going to relate to the area at the moment, but if I gave you an example, let's say I want the integral from 1 to 2 of 3x squared dx, then using this method we take f, which is an antiderivative. So what we do is we take the integral in the regular in the old sense, which is the function x cubed,